Welcome back to The Explainer. So you've landed an on-site interview at your dream tech company. You're scanning the schedule, and boom, your eyes stop dead on the system design session. Panic sets in, right? It's notoriously intimidating. It is literally the ultimate test of your engineering mettle. But hey, don't worry, because today we're going to break down a proven, highly structured framework from Alex Su's Insider Guide that will turn this massive obstacle into your absolute best opportunity to shine.
We've got a lot of ground to cover. We'll start with the system design challenge itself, then move through a 4-step framework, scoping the problem, doing a high-level design, diving deep, and wrapping up. Finally, we'll hit some essential do's and don'ts.
Section 1. The System Design Challenge.
Okay, let's just acknowledge the elephant in the room. The sheer anxiety of being asked to design a massive, globally distributed product from absolute scratch. The prompt is usually incredibly vague, like, design a well-known product. And your immediate thought is probably, are you kidding me? How on earth could anyone design a popular product in an hour that took hundreds of engineers years to build? Well, the good news is, no one actually expects you to. Real-world systems like Google Search are deceptively simple on the surface, but insanely complex underneath. The interviewer isn't looking for a perfect production-ready system. What they really want is to simulate real-life problem-solving. They want to see exactly how two coworkers collaborate on a super ambiguous problem.
To really understand what not to do, let me tell you a quick story about a kid named Jimmy. The teacher asks the class, "Why did the tiger roar?" And before she even finishes the premise, Jimmy's hand shoots up and he yells out, "Because he was hungry." You know, Jimmy just loves being the first to answer, whether he actually grasps the specific context or not. Well, in a system design interview, being Jimmy is the ultimate trap. Jumping straight into a technical solution without pausing to think or clarify the actual requirements? Yeah, that's a massive red flag.
So, how do we avoid pulling a Jimmy? We use a structured 4-step framework. This framework is literally the antidote to the Jimmy approach. It gives you a concrete map to navigate all that ambiguity, allowing you to demonstrate your design skills, defend your choices, and handle feedback constructively, all while managing that ticking clock.
Step 1. Scope the problem.
Remember, this step simulates two coworkers at a whiteboard. You absolutely must ask clarifying questions. Here's what that collaboration should look like. You aren't expected to guess the scale, so you need to ask targeted questions to establish the boundaries. If you ask about daily active users and they say 10 million, that instantly tells you if you're building a tiny startup tool or a highly scaled system for an established tech giant. And trust me, the solutions for those two scenarios are wildly different.
Let's apply this to a real-world example we'll be using today. Designing a news feed system, kind of like Facebook or X. Before you draw a single box, you need to clarify things. Is this for mobile, web, or both? Are we supporting just text, or do we have to handle the massive storage needed for images and videos? Getting this scope locked in up front ensures you don't waste 40 minutes building the completely wrong system.
Step 2. High-level design.
This is where you sketch out your initial blueprint. But here is the real secret sauce. Treat your interviewer as a teammate. You want to draw simple box diagrams for things like web servers, databases, and caches, and you want to do your back-of-the-envelope calculations out loud to prove your blueprint actually fits the scale constraints you just scoped out. Talk through your thought process and secure their buy-in before you move forward.
And this brilliantly illustrates what a good high-level blueprint looks like for the first part of our newsfeed example, feed publishing. Notice how clean it is. A user hits the DNS, the request routes to a load balancer, and then to a cluster of web servers. From there, it splits into logical microservices. You've got a post service to store the text in a database, a fan-out service to push it to friends' feeds, and a notification service. It's highly readable, and it immediately shows you grasp the overall flow of data.
The second core flow is the news feed retrieval, when a user actually opens their app to read the feed. Again, we keep it high level. User to load balancer to web servers, routing straight to a dedicated newsfeed service which simply fetches the pre-aggregated feed from a cache. By presenting these two simplified box diagrams, you secure your interviewer's agreement on the foundational architecture before you get dragged into the weeds.
Step 3. Design deep dive.
But hey, a quick word of warning before we dive in. During this step, a good interviewer is actively hunting for red flags, and the biggest one is over-engineering. This is a real disease in the tech industry. It's when engineers get absolutely obsessed with design purity, completely ignore practical trade-offs, and fail to realize the compounding operational costs of their complex systems. Companies pay a massive price for this ignorance. Do not demonstrate this tendency. Keep your solutions pragmatic.
Now, what's really interesting is how our previous, simple blueprint has evolved into a true deep dive for feed publishing. Look at the fan-out service now. It's not just a basic box anymore. It queries a graph database to get a list of friends, pulls user data from a cache, drops the tasks into a message queue to decouple the workload, and uses fan-out workers to finally populate the news feed cache. This proves you understand exactly how to scale a specific, high-traffic bottleneck.
Similarly, our retrieval deep dive adds crucial layers for performance. We've thrown a CDN at the top for media assets, ensuring everything loads blazingly fast globally. The newsfeed service now explicitly pulls from both user caches and post caches. But notice what isn't here. We aren't wasting precious time detailing the crazy complex machine learning of Facebook's EdgeRank algorithm. You have to manage your time and avoid unnecessary details that don't actually prove your ability to design a scalable backend system.
Step 4.
Wrap up.
The hour is almost up. This is your chance to polish your work and leave a lasting, positive final impression. Now, a pro tip here. Never, ever say your design is perfect. There is always something to improve. Show your critical thinking by proactively identifying potential system bottlenecks. Discuss error cases. What happens if a network loss occurs or a server fails? How do you monitor metrics? Giving a quick, confident recap of the design choices you just made will serve as a fantastic closer.
Finally, Section 6. Essential do's and don'ts.
Let's summarize the behavioral takeaways, because how you act in that room is literally just as vital as your architecture. The crucial point is understanding this dichotomy. The successful candidate asks for clarification, communicates constantly, and genuinely treats the interviewer like a teammate. They suggest multiple approaches and bounce ideas around. On the flip side, the narrow-minded Jimmy jumps straight to a solution, thinks in total silence, and shows stubbornness when challenged. Avoid the don'ts, and you'll immediately stand out from the pack.
To wrap up this explainer, I want to leave you with a provocative thought, which is a classic wrap-up question you might face. How do you handle the next scale curve? If the system you just beautifully designed for 1 million users suddenly has to handle 10 million tomorrow, what breaks first? By constantly asking yourself how a system behaves at the next order of magnitude, you'll train your brain to think like a true architect. Keep that question in mind as you tackle your own designs, and I'll see you in the next explainer.